Okay, greetings. Welcome back. This is lecture number 7 of our online experience here in CSI 121. Tonight there's no video, not for any particular reason, just I think that we need to get into some stuff that's complex, and we're going to spend a lot of time working on code. I've already spent some time working on code, and I'm going to try and highlight some of the slight changes that I've made so far. So if you remember last time, and I'm going to share our slides here. If you remember last time, we ended up right here. That was, we had a working example program that had a stack that was completely independent of the application data. And in fact, we had created a class called AppData that included that single character that we needed. And we had to rewrite some code. And so I really want you to be careful about this stuff. You know, the stuff I was doing in code is not really straightforward. And our book glosses a lot of this stuff. And so when it comes to the book's description of some of the things that we've just gone over, and some of the things we're about to go over, the book could be a little better written. Now, that said, the reason that we had you buy this textbook is that books that cover this material a little bit better cover the other material much worse. And so I can tell you that Shem and I looked at probably a good 6 to 7 textbooks, prospective textbooks for this course before settling on Savage's book. And in particular, we looked at Deitel and Deitel. We looked at who else? Nijhoff. Boy, I can't remember the authors now. So anyway, pay attention to the lectures, take notes, and when you see me writing code, you should be sitting there writing in the code and getting your programs to work just like mine do in the lecture. Okay? So now we're gonna take AppData and we're gonna make it contain more stuff. And then we'll show that we can use a stack without having to touch the stack code at all. And that will allow us to use that stack code with any data, not just a single, excuse me, sorry for the yawn, not just a single character, but for any data we would want to put into that stack. All we have to do is just name our class that holds the application data. We need to name it AppData. And in fact, it turns out we don't even have to do that. And I'll show you how. So, in here, we're going to start slow. I'm saying I'll alter sensor.h and sensor.cpp to create a new AppData. So I'm pulling that sensor.h and sensor.cpp from lecture 3. And so that code you should have followed along in lecture 3, saw that code written, hopefully wrote that code. If you didn't, go back to the latter parts of that lecture 3 video and take a look at what sensor.h and sensor.cpp looked like. So I'm going to share out. So I'm sharing out now the window that I've been doing my programming in. I've been bouncing around a lot, so I'm just going to clear this screen and then do a nice little ls. I've already renamed sensor.h and sensor.cpp to be appdata.cpp and appdata.h. Going into appdata.h, okay. This is still the sensor class. And in fact, there's that name, class sensor. I haven't changed the class name for the sensor, but down here is a little bit of C and C++ magic. And that's called a type def. A type def just basically gives you a new name for an already existing type. So maybe I don't like int as my type for integer. I could call it whole, and then HOW or WHOLE, whole, could now be used to define variables, and those variables would be exactly the same as int. So here what I've done is I've included right at the bottom, after I've set up my specification for the sensor class, I've said type def sensor app data. And that basically just says, here's this existing class sensor. It's an existing type, and we're going to give it the same, another name, and that name's going to be app data. And so that's a real simple way for a programmer to do this. And in fact, I really don't even have to do it here. I could have done it in our example programs main and had that work as well. But for this example, I put it in the appdata.h file, which is really just the old sensor.h. There's one other change in here that I made, and that's right here. In the original sensor class, that was called print sensor. And so I've simplified it down to the same print name that we used in yesterday's example. And so yesterday's example combined with this new sensor class is going to allow us to build a stack out of sensors. And so this is all going to look like app data to the program that we write. Now, since I changed the name of that print member function, I have to change that in appdata.cpp as well. And so if you notice, my cursor was already sitting right down here on the print, and I had already changed that from print sensor to just simply print. Okay, so I can get out of here. The names of those two files were changed so that I don't have to change any of the includes in stack.h. And so if I look at stack.h, that's just our standard stack definition, exactly the same as it was before. I haven't changed it. If I go into stack.cpp, again, exactly the same as it was before. I haven't changed a darn thing in here. Not one single line of code. Okay? And now I'm going to edit our example8.cpp. So this is yet another example program. This is our program from yesterday. And so I need to make some changes in here. First and foremost, oh, actually, this is, obviously I started making changes in here and then quit. This should be app data. So I'm including that app data. I really don't need the const max string length because this doesn't have a string in it. So I'm going to get rid of that. I've got temp data and app data, int I. Wow, this is not, I'm gonna go back just a little bit. So somehow I got some edits in there, but not all. So I'm gonna copy, from lecture 6, EX, that was ex7.cpp, and I'm gonna copy that to ex8.cpp here in the local directory. So now I should have exactly what we had yesterday. And I do. Awesome. Okay, so this includes app data, the way it did yesterday. Sorry about that little mix up with the example 8 code. I'm going to get rid of the string length, the max string length. We don't need that. I also don't need this character here, the character array. That was for yesterday's example, and quite frankly for program 5 as well. I'm going to leave in int I, but I'm going to add a D to it, and so I'm going to call this int ID. Okay, here, what is, and for now, I'm just going to say what is the sensor ID. Okay, that's going to need me to see in the value of ID. I don't need a for loop. Get rid of that. Get rid of that. I'm going to re-indent. Okay. And then I'm going to put in a blank line just so we can see what was going on in here. Now, this is where I'm the application programmer right now. I've got my application programmer hat on. I don't know nothing about no stack implementation, but what I do know is about my application data. And so my application data has in it a set ID. And so I'm going to call that application data mutator or setter, and I'm going to say set the ID to the one I just read in from the keyboard. Okay, I'm going to push that onto the stack. Then I'm going to print the stack, and then I'm going to do that loop that we had in the prior program where we pop everything and print it out as we pop. And that might be all I have to do, at least for now. So I'm going to G++ this, ex8.cpp, appdata.cpp, and stack.cpp, similar to what we did the other day. And I'm going to produce an executable that's called ex8. Okay. I just don't like a.out. And look at that. My changes to app data, so bringing in that new sensor stuff, was pretty simple for me to change that to make it look like app data. In fact, giving it the name app data that doubles for sensor. No changes to the stack code. Very little changes to my application, you know, my test application or my test program. And now let's see if it works. So I'm going to run ex8. I've got to wait for the stupid virus checker to say, yes, this is not infected, which is what we hope for all of us, is that we're not infected. Of course, the sensor's ID number must be 42 because it's always 42. And there's the dump of our stack. And there's, so right here, we took 42, we set it in that temp data, we stacked it, we printed out the stack right here, and then when we're done, we print out each of the items as we're emptying them, okay? So one by one. That worked. That was frighteningly easy. Now, you have to know the right places to make little changes, but as soon as you do, I was able to simply tweak a little bit of code, and now I've got a stack of sensors, not a stack of characters. That's what we're after. This is what object-oriented programming is all about. This is the power of object-oriented programming. The power of you being able to write code and have it, work with a variety of different objects, a variety of different types, and you can reuse that code with very little, and in some cases, like the stack, no changes to the code whatsoever. So if I wanted to change app data now, I could change app data into pretty much anything I wanted. And in fact, I don't even have to create a class called app data, as I just showed you. And let's go back in and look at that. That's in appdata.h. I'm still calling my my class sensor. And then I get out of that. And then down here, I'm just using this type def to say, call sensor app data as well. And so now I can refer to this type, to this class, either by the name sensor or by the name app data. Incredibly powerful. And this is what we were supposed to be doing. That is to make things easy for us, to make things simple for us, so that we could easily change our code a little bit, recompile it, and have everything work. So now I'm going to get out of here, and we're going to go back to our slides. So I'm going to stop the share of the window, and now I got to find my slides. Where's my slides? Slides. Show all windows. Oh my goodness. There we go. So indeed, I altered sensor.h and sensor.cpp to create the new app data. I altered our stack example program to use this new app data. I really didn't do all the setters in there. If you remember, what we had was latitude and longitude and the 5 most recent readings. So none of that was done. But what we did do is we tested the concept of changing app data and simply recompiling, and things worked. Our stack worked. Okay. Now you might say, well, we didn't see the stack do anything more than just a single push. So yeah, okay. No, we didn't. But I can tell you, I am absolutely certain that if I went in and added a little bit more code to push a few more things onto the stack, you would see that work. Because I wrote the stack yesterday. I didn't change the code. The stack code worked yesterday. It's going to work today. There were absolutely no changes to stack.h or stack.cpp. So now that we're making app data more complex, there's some things we probably need to do. And, I could test these things in the code. And so why don't we do that? Because we really should have a copy constructor, but the compiler is pretty darn smart about these copy constructors and creating them on the fly, not requiring you to write them. So I'm going to go and write a little bit more code in our example program and test to see if that stuff actually works. So in here, what I really need is several more sensor network nodes. And so I'm going to set up a loop, and I'm going to read in, several of these. So up here, I'm going to add another integer, and I'm going to call that J, for lack of a better term. Okay. And then right here, I'm going to say for J equals 0, J less than 3, J plus plus. And now, let's see, I need to re-indent this. Re-indent this. Re-indent that. Okay. And now I'm going to write a whole bunch more code. And I'm going to space this out a little bit so that each little chunk has its own, each little operation has its own chunk of code. So I'm going to see out what is the sensor's latitude. Need a space, semicolon. I need to go up above and define a couple of doubles. I really don't need 2 doubles. I really only need 1 double, and I'm going to call it TMP. Okay. Now I'm going to use that TMP for latitude, longitude, and for each of the readings. So CN TMP. Okay. And then let me get a couple more lines of code in here. Blank lines. And then I'm going to say temp data dot set lat TMP. Okay. C out. What is the sensor's longitude? Again, I'm going to CN temp. And then I'm going to say temp data dot set lon using the value in TMP. Then I'm going to go up here and add yet another int variable, call that one K. For K equals 0, K less than, boy, I don't remember what that was called. I thought it was max readings. K plus plus. what is the value for reading number. Okay, so I'm going to prompt the user for each of the 5 readings here. If I remember right, that's what max readings was. And then I'm going to cin, and I'm just going to cin these directly into temp. Nope, can't do that. Into temp. I can do that. Never mind. And then do temp data dot set reading. And if I remember right, that had 2 parameters, which was the reading and the reading number. And I don't remember what order they were in. So I'm going to do it that way. I'm going to jump out of here for just a second and take a look at that appdata.h to see what the name of those were. Set new reading, set new reading. There it is. Oh, we don't have a reading number in there. That's right, because this is doing the shuffle for us. Remember, we shuffle all the readings down by 1 and then stick the new reading in at reading 0. Okay. So going back into here. I'm going to change my prompt then just a little bit. I'm going to ask what is the value for the next reading. Get rid of that, and then get rid of the stuff that would have prompted them with the number in the for loop variable, the loop variable. Okay. And so this, and that I was wrong anyway. That should have been a K. So that should be everything I need right there. Okay. So I get the sensor ID, I set it in temp data. I get the latitude, I set it in temp data. I get the longitude, I set it in temp data. I read in 5 readings, and I set those in using set reading. So I'm going to fill up those 5 readings in temp data. And then I need that stack push that I have way down here. Like that. Close off that for loop. So I'm going to read in the data for 3 of these sensors, pushing each time. So temp data is going to get all of its data updated, pushed, all of its data updated, push, all of its data updated, push, and then I'm going to drop out and do print stack. And then I'm going to do this this while loop that empties the stack. Okay. And that should be enough for me to test the need for a copy constructor. Has no members set reading. Oh, notice the error message I just got here? App data, also known as class sensor, has no member set reading. Ah. Very clever. Now, set reading is not what that mutator is called. It's set new reading. And so we'll go back in, recompile, /ex8. Wait for my virus scanner to run. Come on, there we go. So my first sensor is going to be 42. That sensor's latitude is going to be, let's see, negative 23.12. So that's in the southern hemisphere. Its longitude, negative 86.34. And the value for the next reading from it, I'm just going to put these in order so we can see the order of the readings. So it's going to be 1, 2, 3, 4, 5. So that actually should print out as 5, 4, 3, 2, 1, because remember, we're doing the last 5 readings, most recent first. Okay. It asked me for the next sensor ID. The next sensor ID is going to be 2525. That sensor's latitude, 45 degrees north. So positive 45 degrees. Longitude, negative 87.45. So this is somewhere around Gaylord, Michigan. Okay. Value for the next sensor readings, I'm up to 5 on the first one, so I'll continue on with 6, 7, 8, 9, and 10. Okay. What's the next sensor ID reading? 2112. What's its latitude? That latitude is going to be about 42 degrees. 41 degrees. Yeah, 41 degrees. Longitude, negative 80, 82. Yeah, let's go there. Okay. Readings, 11.2, 12.3, 13.4, 14.5, and 15.6. So I just did this because I wanted to make sure that the floats, that the doubles are still working for the readings. I know they are, but I'm still checking it. And what we should get next is a dump of the stack. The stack, if it's working correctly, should have 2112 at the top, 2525 in the second position of the stack, and at the bottom of the stack should be 42. And so here's the stack contents. 2112 is at the top. And all of that data is indeed 2112's data the way I entered it. Then comes 2525 next, and then 42. And then it's done. And now, as I while loop and pop them, I get that. And so this tells me, because I do not see any corruption of the data in here, this tells me that we do not have to do a copy constructor. So the copy constructor isn't required because the compiler was clever enough to do it for us. With that said, though, I'm still going to create a copy constructor. And that copy constructor will get invoked whenever we pass this as a parameter in a function, like we do in the push and pop, and like we do in Let's see. No, we wouldn't use it there. It would just be like in push and pop. Oh, nope, that's it. Awesome. Okay. So I'm going to stop the share. Okay. Wow. My window's freaking out here. So I'm going to go back to sharing the PowerPoint slides. Okay. So I'm going to show you how to build a copy constructor because you need to know how to do that. Particularly, stop that. Particularly when we're dealing with data structures like the stack, like a queue, like a linked list, you will have to do your own copy constructor. In these simpler classes without dynamically allocated memory, you actually don't have to do the copy constructor. The compiler's smart enough to figure it out. But I would much rather start now showing you what the copy constructor looks like, simply because you know, you start simple, you build on those ideas. So the textbook's pretty sparse on the copy constructor. The code for the copy constructor is really very much the same as the code for the assignment operator overload. Again, saying, you know, object equals object. And then the overload for the stream insertion operator, so that we don't have to call those print functions. We can just do cout and then the class, and it will do it. And so we'll take that print function and we'll turn that into an overload of the stream insertion operator. So those are the three things I'm going to do next. I've got about 15 more minutes in this lecture, and so so we might get through all three of those things, but I have my doubts. So the copy constructor versus the assignment operator overload. They look very similar. The code looks very similar in these. Each of them takes a parameter. In a copy constructor, that parameter's name is usually original. So the object's name is original for the parameter. In a assignment operator overload, we usually have it as RHS or right-hand side. And that's because you're talking about that equal sign, the assignment operator. What's being passed in is the right-hand side. A copy constructor does not return a value. However, the assignment operator actually should return a value, and our textbook does not show us how to do that. And so this is where I'm going to rely on a different textbook's coverage of the assignment operators. And so there's a reason why you want that assignment operator to return the value. And it's because in C and C++, you can do things like A equals B equals 3. And the value 3 will be set to B, and then it will be passed along or returned and then set to A as well. So you can actually write A equals B equals C, or excuse me, 3 semicolon, and it will set both A and B, the variables A and B, to the value 3. It's a shortcut, but if you don't set up your assignment overload, your assignment operator overload correctly, having that return value, then you can't do that equal sign chaining. And so this is really a niggling piece of code that we have to do, and it's got some stuff in it that's kind of weird. So I'm going to pull this from a different source, and I'm going to cover both of these in more detail than our book does, because our book just doesn't cover this stuff in much detail. So first off, the copy constructor. All copy constructors have the form of the class name and then a const object of the class type that is a reference to the original. So let's add that prototype to our specification and then the code in our implementation. So I get lost in the shares, and I'm just going to bring the share back up here. Yeah. Okay. So in here, this is all going to go in appdata.h and appdata.cpp. And right up here, right after the constructor and the destructor, I am going to create the copy constructor. The copy constructor is, remember, it was class name and then a const of the same class. So this is sensor. And then inside of this is a const sensor ref parameter called original. Okay. That's the prototype. That's all it is. I'm going to put in a comment here that says copy constructor. And now I've got to go over to appdata.cpp, and I also have to put that in here. So I'm going to put this up where the constructor and destructor are. I'm going to put it right after the constructor, even though in the .h it wasn't in this order. That doesn't matter. So this is sensor, sensor const sensor ref original. Okay. Get rid of that. Get rid of that Vim problem. I don't want any C indent. Okay, and so this is going to introduce a new idea. And the new idea is a little bit weird. It's referring to, actually, I don't even need to do that, do I? I don't. Never mind. So ID is the local object. This is the one we're copying into. And the original, I have to get the ID out of. We are not in the same object. Okay, so we're in a copy of the object, basically, and we're copying this stuff over. And so I actually need to do a get ID here. Oh, get ID, not set ID. Okay. That's a little weird. I'll grant you that. Then I'm going to do the same thing with latitude, which is equal to original dot get lat. The same thing with longitude, lon equals original dot get lon. And then I realize I need an integer up here. Just call it I, because why not? for I equals 0, I less than max ooh, yeah, okay. I was concerned there for a second. I plus plus, okay. And then inside of the loop body of the for loop, I'm just going to have readings sub I are equal to original dot get reading I. And there isn't a return needed in there. I guess I could do a return if I really wanted to. So I will. But it's not returning anything. If I've done everything right, this should, here we go. This should all recompile. Okay. What's going on here? In copy constructor, sensor get const sensor, error passing const sensor as this argument discards qualifiers. Hmm. That looks suspect. So, got to make sure of what I'm doing here. I'm looking for a good code reference for this. Copy constructors. Copy constructors. Well, crap. What time is it? I'm looking to see if I'm out of time. And I've got about 4 minutes, so I'm going to look this up real quick. I thought I had gotten all of the little bits and pieces correct, but I might not have. So 339, 339, 339, 339. Okay. There's a destructor. There's a copy constructor. Well, I don't believe that works for a second, but maybe it does. Let me try it. Go down here to the copy constructor. See, these are different objects, and I was convinced that I could not access the private data in that object. But my other textbook that I'm using is saying I can do this. And that seems sketch to me, but yeah, we'll try it. So let's try that. Oh, wow, it worked. Been programming in this language for over a decade and a half, and it still surprises me sometimes. I thought I knew something, and it turns out I didn't. This is the thing about working in computing. You never know a language completely. If you do, then the language is so simple as to be unuseful. So that's a copy constructor, properly prepared and properly coded. So I'm going to go back into that copy constructor, and so you can take a look at it a little more closely. Original is the thing, like if we had called a function, original would be the object that was passed into the function, and the thing that I'm inside would be the equivalent of the parameter, the formal parameter of the function. Okay, so now I want to overload the assignment operator, and the assignment operator overload is essentially the same thing. That code is going to be very simple, and in fact it's the code that we just looked at. Calls to constructors and destructors, the class destructor, the copy constructor, the assignment operator overload. Here we go. So let's get out of here. We go back into appdata.cpp. Okay. Or not appdata.cpp, that's where I just was. I want to be in appdata.h. Okay. So right now I'm going to stop the sharing. I'm going to go back to my slides. So that's the copy constructor. And I am out of time for today. Tomorrow we'll come back and work on the assignment operator overload and the stream insertion operator overload for these. And that's my timer telling me that, that I'm done. So, talk at you tomorrow. Go back, make sure that, I strongly encourage you to type in the code in these lectures, to run the code, to compile and run the code. And if you get a compile error that I didn't get, then go back and look at the code and make sure that you've got it character for character. We're in shutdown now, which means some of you might not have good internet to watch these videos. I certainly don't have good internet to upload them. And that's why I'm not doing sort of video of myself, because the amount of data that it takes for one of these lectures without video, with just the shared PowerPoint slides and the shared terminal window, that drops the data enormously. If you are struggling at all, whether it's academically or emotionally or, financially, don't just draw in upon yourself. Let me know. I think I said this in my email to my advisees, but I'm going to say it to all my 121 students right now. If you are going through financial hardship because, suddenly your part-time job no longer exists, if you're going through emotional hardship, certainly the counseling center you can call in. I believe they're still holding hours. Drop me a line and I will try to get you the help. I'll talk to financial aid. I'll do whatever I can if you are struggling. Do not just sort of close in on yourself, okay? stay connected, stay engaged, keep up with the lectures. We can get through this. We will get through this. And for that, I'll see you again on this channel tomorrow. Take care.